Good morning, everybody. Welcome to the help session. Help session number 1. We will not be using the PowerPoints. We'll be just using the board, okay? So let's start with the super mesh example for the ultra checkpoint, okay? So we want to solve the ultra checkpoint using the super mesh. So what we have is we have a 40, 17.4, 15, 4, 10, and then here we have a 0.1 going this way, then we have a 26, and then we have so ohm, 15 ohm, volts, 4 ohm, 10 ohm, and then we have the terminals A and B. How to solve this example? Well, we said we want to have a super node and a regular node, okay? And then we said I sub A, I sub B, I sub C, okay? Okay, if you cannot see, you can come and sit here, that's okay. Now, Dr. Ahmed's student, we're explaining a little bit different, okay? But it's the same thing. So what I proposed is we said plus minus, plus minus, plus minus, plus minus, plus minus, and don't forget to define the currents that enter where they enter. So for example, here we have what? IA minus IC. Here we have IA minus IB. Here we have IB. Here we have IB. Here we have IC. We are professionals. You cannot proceed until you make sure the circuit is drawn properly. For Dr. Ahmed's students and Dr. Atiyah, you put the positive sign in the direction of the loop, صح? And then you say it's plus when you do the KVL. For my students, do whatever you want. Get it? If you want to put plus minus or plus minus, it doesn't matter as long as you define the currents properly. If it happened, which will not happen if you use Dr. Atiyah or Dr. Ahmed, my students, if it happens, you got the current, like the quiz for section 2, homework, problem 8. If the current enters through a negative, do not forget the passive sign configuration. So we come to the most important note that I need you to memorize. We have passive sign configuration. It comes at P equal plus or minus VI or V equal plus or minus IR. Today we included the capacitors, but it's not part of the test, okay? Now, how to set up these equations? It's a super mesh because we have a current source that we cannot know the voltage drop across it. So that's a very important concept. Loop number 1, voltage rise, voltage drop. Voltage rise, plus 17.4. You have to use minus, okay? Because you see a negative sign. Get it? So I'm going to write your equation here, minus 17.4. See it? Not going to show it in the camera. Now, voltage rise or voltage drop? Drop minus. I don't care. What's the resistance? 40. What is the current? IA minus IC. Voltage rise or voltage drop?
Drop.
15, right?
Yes.
So it's minus 15. You put plus. So you say plus 40 times IA minus IC. And then you put what? Plus 15 times IA minus IB. Equal? 0. So here, do not look. Okay, my students, don't look. Okay? It's only for Because I want to show you it's the same thing, it doesn't matter. It's like x equal 3 minus x equal minus 3. It's the same story. Equal IA minus IB. Sit here, please. So, close, behind. Sorry, Dr. Ahmed, student?
Junaid. Dr. Junaid.
Yeah, but Dr. Junaid is not teaching. This is EE234.
Industrial.
Oh, you're to industrial. Welcome. We're doing super mesh. Industrial engineer. Okay, sorry. So we said voltage rise plus 17.4 minus 40 times IA minus IC minus 15 times IA minus IC. Some professors explain this to be minus 17.4 plus 40 IA minus IC plus 15 IA minus IC equals 0. 1, 2. Get it? Okay? Is this equation different than this equation? No, the same. Now, how do we do the super mesh? It starts from where? Who wants to be the KVL? You. You're here. What should we do? This is 10 ohm.
Minus drop.
Minus 10. What's the current? IB.
IB.
You're here.
Minus
4. IB. Voltage rise or voltage drop?
Voltage rise.
Plus 15 times
15. A minus C.
IA, not A. IA
minus
minus IC. IB.
IB.
Keep in mind, if you're using the other section, you see IB minus IA. Right? Because you define the positive here and the negative there. It's IB minus IA, right?
Yes.
Super mesh. We are going across this loop. KVN around loop اللي شكلها زي المسدس. That's why we're doing super mesh. This is a super mesh example. 15 IA minus IB, and then we're going to the left.
Rise.
Plus, what's that?
5.
No, it's 40.
IA minus IC.
And then we go here, voltage rise or voltage drop.
Drop. IC.
Minus 26 IC, and then we end here. Equals 0. If we're gonna use it using Dr. Ahmed method, what is the equation?
It will be the opposite.
So it will be
Positive.
plus 10 IB plus 4 IB. And then how to define the equation here? You will put plus minus plus 15 IB minus IA. And then when you go here, it will be plus minus 40 IC minus IA, صح? 40 IC minus IA, plus minus, صح? And then if you go here, it will be plus 26 IC. Because you put positive in the direction of the loop.
Yes.
صح? That's the difference. Stick with your professor method. Equals 0. What's the difference between this equation and that equation? It's minus, minus. We flipped IB minus IA, we flipped IA minus IC, and then plus 26 minus 26. So it's just the negative. So minus whatever equals 0 is the same. Get it? That's the only difference between the two methods. And then the last equation, what is it? The mesh. So we have a current source that has IB going here, IC going there. So that's a 0.1. So IB minus IC equal 0.1. Both methods are the same. IB minus IC equals 0.1. IB minus IC equals 0.1. From here, can you solve it? 3 equations, 3 unknown. I'm not going to solve it. I'm going to solve our system. What is our system? What's the size? IA,
3 by 3.
IB, IC, charity pin. What is the coefficient of IA? Minus 40 minus 15, minus 55. For IB, minus 15 times minus 1, plus 15. For IC, plus 40, equal 17.4. It will, we move it here, the D column, to the right. It's minus 17.4. Can you confirm?
Yes.
Correct. Line 2, 15 plus 40, 55. For IB, minus 15, minus 4, so minus 15 minus 14, minus 29. For IC, minus 40 IC, minus 26, minus 66. Equals,
0.
there is no constant. The last equation, it's easy. 0, 1, minus 1 equals 0.1. System solvers. What is IA? What is IB? What is IC?
IA equal 0.74.
0.74 amps. Don't forget the units.
Yes.
Even in the test, don't forget the units. Take it as a good habit. What is IB?
0.5.
And IC?
0.4.
Check. 0.5 minus 0.4 is 0.1. The question asks about what is VAB, the V open circuit. The V open circuit in the ultra checkpoint, we already calculated R Thevenin. Check the video from last week. The V open circuit is the voltage drop across the 10 ohm resistor. What is the voltage drop across the 10 ohm resistor? So VA, B equals VA minus VB, it doesn't matter, equals 10 times IB, which is 5 volts. Is it clear, the ultra checkpoint? Does it match the answer? Now this question is in Dr. Atiyah's slides. This question, we solved it in the class using node voltage method. Now we're solving it, or we did solve it using super mesh method. Is it clear? Okay, question, Muhammadi?
دكتور
We go back to you, Adnan.
الاي اي والاي بي والاي سي عندي في المعادله طلعت غير. باقي الارقام مش معي. هل المشكله في حسبتي ولا المشكله وين؟ لاحظت كذا مره يعني في اكثر من حسبه.
Is this correct?
لا.
Okay, this one we did it analytically. Come, bring your calculator while I ask the question of Adnan.
So, Doctor, what is the criteria when you see the circuit? I always think of direct using super mesh.
Usually super mesh is if you have a current source that is connected between two nodes. A super node if you have a voltage source that's connected between two nodes. Okay?
Instead of ohms, instead of resistance.
Yes. Remember, I can always tell you how many elements we have studied. Voltage source, current source, and a resistor. If you draw a table, voltage and current. For voltage, it's known. For current, I don't know. For a current source, it is known. For the voltage, I don't know. For the resistor, V equal IR, the current is V over R. That is why. If you don't know how to do the calculator, come to me right now. Don't bring surprises on Thursday. When is your major exam, 204?
Thursday.
Thursday.
Yes.
Do you have a super mesh?
No, I don't think so.
Okay. You learn something new. Minus 55. 15, 40, minus 13.4, 0. Why you put minus 0.1? No, it's IB minus IC equal 0.1. Do not shift it.
ما قلت لك ان شاء الله.
No, it doesn't matter if you change it. It will change.
يعني حتى نفس ما
No, you have to keep that. If you mess up one sign, everything will be wrong. So what you did is you thought that this is plus 0.1 equals 0. No, it's minus 0.1 equals 0.
هل هذا دكتور
No, you
حط الطرف الاخر.
No, the D column is whatever.
Same.
No, whatever here. So it's ax plus by plus zy equal d. So d is the constant 17.4, it becomes minus 17.4. اللي بعد يساوي هو الدي. الآلة الحاسبة غبية، هي تحط لك كذا A B C D، بس أنت تخيل إن في تساوي هنا. فالدي هي الطرف الأيمن. واضح؟ فال 17.4 في الدي في المصفوفة هي minus 17.4. This is a very common mistake. واضح؟
واضح.
الدي هو الطرف الأيمن. الدي هو إيش؟
طرف اليمين.
الطرف الأيمن. ريان؟ عبد الله.
لو استعمل مش يساوي اي بي ماينس اي سي يساوي 0.1.
Well, it's not B minus, be specific. I sub B minus I sub B minus I sub C equal 0.1.
اقدر استعمل مش ميثود سوبرفيشن.
ما تقدر تستعمل مش ميثود لأن هذا الفولتج دروب هنا ما نعرفه. لما تسوي لوب ما نعرف الفولتج دروب على الكرنت سورس. علامة استفهام. Okay? Any question about super mesh? Now we will move. Supernode today I made a mistake. So we will resolve it, okay? Can I erase it? Okay. Yes.
Why we reverse the sign for resistance?
It's not why we reversed. If you put it minus and plus, it will be a voltage rise. But because IB enters from the negative, you have to fix it with a negative sign. So ultimately, it will be minus 4B times IB. Minus 4 times that. If you put minus and plus, passive sign convention will get you. If you use plus minus, no passive sign convention, but it's a voltage drop. So by passive sign configuration حطيناه علشان نصحح الأخطاء لما يدخل التيار من السالب. Stick with the procedure and it will work. Trust me. Okay? Yes.
انا حاط دايم الريزستور تحت حط الموجب.
That's what I told you as a good trick. Why? Because we want to see more voltage drops than voltage rises. Okay?
بس فوق نخليها يسار.
يعني to make things you can put minus plus. It's up to you. Doesn't matter. However, once you see a current entering from the negative, passive sign V equal minus IR. You studied passive sign configuration? Okay.
بس بساعد دكتور احطها في كل اي ولا
Passive sign only if you have a current entering through a negative resistor. The current entering through the negative current.
طيب عندنا الريزستور يا دكتور اللي توافق فيه مثلا اي بي واي سي. والاي بي في البدايه دخلت من النيجاتيف. لكن عند الريزستور لا دخلت مع البوزيتيف ما حطها الباسيف ساين.
بس يطلع لك فولتج دروب. صح؟ ما بتشتغل في كلا الحالتين. Try, you have to solve it.
زي الكويز يا دكتور.
الكويز what we had in the quiz is problem 8 in the homework. We had a resistor here, صح? We said plus minus and we had IA here. So what's the voltage? Voltage rise or voltage drop? Rise. IA times R. It enters from the positive. We have to put a negative sign. If I put it that way, minus and plus, IA, then when we do a KVL, it's voltage rise or voltage drop? Drop. IA times R. هل هذه نفس هذه؟
ايوه يا دكتور بس لما يتقابلون عند زي الكويز الهوريزونتال ريزستور يتقابل فيه الاي سي والاي اي.
This one?
ايه.
Whenever you say plus, you have to define the current here, and then the current here will be IA minus IC.
نحط ماينس عند الاي اي.
لا ما تحط ماينس لان الاي اي هي تدخل مع الموجب، الاي سي محطوطه فيها الماينس انها تدخل مع السالب. خليها زي ما هي اي اي ماينس الاكسرسايز اللي ريفرنس ابورد ريفرنس داونورد ريفيود.
اليسار حطيناها نيجاتيف عشانها تدخل من النيجاتيف صح؟
Yes, this negative is because of the passive sign configuration. This negative because it's a voltage drop. That's why I prefer my method because it distinguishes between the two concepts. There was a mistake that I made today in the lecture. I need to correct it. It's a numerical mistake. I think I put minus 15. It should be plus 15, something like that. What is the circuit? The circuit was, we have R1, and we have R2, R3, R4, voltage source, plus minus 10 volts. And then here we have what? Minus 15. And then we have a ground. So we call this R2, we call this R1, we call this R4, we call this R3. Okay? What did we say about the supernode? First of all, you have to understand, because the battery is flipped, what was the voltage? 15?
I think 15 is.
So 15 volts here. What is the voltage here at this node?
minus.
It is V3 equals minus 15 volts. Now, in the past I told you at node voltage analysis, if you have a voltage directly connected to the ground,
Yes.
then this is a known voltage, so do not include it in the node voltage analysis. So what are the unknown voltages? We have here V1, we have here V2. And I told you in node voltage analysis you have to do IA, IB, IC, and here you have to do ID, IE, and IF. But we have a problem. I cannot calculate the current that goes through the voltage source. So this voltage source, I cannot calculate it because we don't have a resistance here. That is why we have the problem of a supernode. So the scientists, they called the whole V1 and V2 a supernode. So this is supernode. And they told you, forget about the currents that enter through the voltage source and look at only the currents leaving the supernode. So we call them IA, IB, IC,
ID.
an ID, and you need to add a constraint equation later. So how many unknowns? 1 and 2. So let's write the equation. V1 minus 0 over R2. This is what? This is IA. Plus V1 minus 15.
Plus.
It is V1 plus 15 over R1. So we finished IA and IB. What is IC? V2
minus 0
minus 0
over R4.
over R4. What is ID? V2 plus 15
Yeah.
over R3 equals 0. That is equation 1. 2 unknowns. We still need one more equation. The unknown equation is V2 minus V1 equals 10. V2 minus V1 equals 10. You have to convert it into the standard form. What is the size of the matrices? 2 by 2. V1, V2. What are the coefficients? R2 inverse plus R1 inverse. I'm writing it that way. It works, صح? It's one. I'm lazy. What are the coefficients of R2? R4 inverse and R3 inverse. Coefficients of the second equation, minus 1 and 1, equal. The constant we have minus 15 R1 inverse, minus 15 R3 inverse. Minus 15 over R1, minus 15 over R3. Equals 10.
R3 دكتور inverse.
Yeah, 1 over R3.
لا الاعتصام.
You're right. Equals 10. Keep in mind the constraint equation always equal to something, so no need to shift it. Okay? And then you solve the system, and now you solve the supernode. Okay? I think the two bad news now are easy. So, yeah.
ليش V2 ما ينفع؟
Because V2 minus V1 is 10 volts. V1 minus V2 is minus 10. V2 is 10 volts higher than V1.
Oh, okay. So,
The meaning of a voltage source, if you are, why I call it voltage rise? Let's say you are here. Your voltage, let's say at the ground level, so you have a 0 volt in your hand. The moment you jump here, you gained 10 volts, so it's 0 plus 10. Get it? So V2 is at a higher potential than V1 by 10 volts imposed on it by a battery. مفروضة عليها. Remember, the voltage drop, if I say V3 is minus 15, it's with respect to the ground. V1 is with respect to the ground. V2 minus V1 is 10 volts because both of them are with the same reference.
إذا ال V3 ماينس هل أتوقع V1 و V2 تكون ماينس ولا؟
I don't know. It depends. It depends on the R's, the Amperes, the system of equation. I'm not going to solve a numerical example, okay? I think that's more than enough.
عندي سؤال. كيف نحدد النقط البعيدة عن السفن؟
النود is
النقط كانت سالفة اكزامبل يوم جاء الهوم ورك طلعت صعبة.
well, it wasn't hard. I think you're talking about the homework that has a 3 at the bottom.
Yes, and it's question number 2.
Yeah, so in the homework you had a resistor, a battery, and a resistor. So are those elements in series?
Yes.
Yes, they carry the same current. So this resistor, you can mix it with that and make it simple. This was the trick in them. You need to simplify that branch. If you do source transformation, don't you simplify series resistors? And by the way,
voltage source ما يختلف.
no. Voltage source, plus minus, resistor, another plus minus. You can find an equivalent for one resistor and one voltage source. If they are in the same direction, if this is 5 and this is 3, then this will be 8. If this is 2 and this is 2, this will be 4. Get it? In series, you can add them.
Even the voltage you can.
Yes. If I bring you a question tomorrow on Thursday, what is the voltage drop across AB? 2, 1. What is the voltage drop across AB? 3. Okay, what if I put minus and plus? Minus 1. Again, do the KVL. Voltage rise, voltage drop. Minus VAB. Minus 1 plus 2 equals 0. So VAB equals 1. It's KVL. If I bring you in the test, what is the voltage drop across AB?
5.
Anybody who doesn't know that this is equal to 5? Raise your hand, that's okay.
ما نسوي كيبل والريزستنس
That's an open circuit في الهواء. Open circuit. سلك معلق في الهواء، كيف يمشي فيه التيار؟ كيف شاحن؟ I don't have any cable بس سلك معلق في الهواء، سلك معلق في الهواء، تمسكه بتتكهرب، لازم تصير now. In V open circuit like that, that's why we call V Thevenin is V open circuit. Get it? سلك معلق في الهواء يا شباب. You have a 5 volt and you connect it with a cable. You put your hand, will you get electrocuted?
Depends on the.
No.
No,
No. No. When you put your iPhone in the charger, will you get electrocuted? No.
لا لا السلك دكتور هو
No, it never does that. والله أتحداك. أتحداك تلمك سلك شاحن مسبوك بالكهرباء وتتكهرب، أتحداك. مستحيل. ما راح تتكهرب إلا إذا كان فيه إذا كان في جهد عالي أنت بحيث تصير أنت شورت سيركت. وهذه على الهاي فولتج ابلكيشن. You need to close it. Now when we apply our Thevenin, the way it works applying our Thevenin أنت تحط fake system اللي هو الأوم ميتر. لما تحط الأوم ميتر أنت تقفل التيار فيصير في كارنت يمشي فتشوف الار Thevenin هي هذه. بس بي اوبن سيركت لما تشوف two terminal device وهنا AB الكرنت I equal 0 for V open circuit always. When you put R Thevenin it's another story. I'll explain it. Now let's start with the source transformation. Why we love source transformation?
Simplify the analysis.
It simplifies the analysis. So if I bring you a question in the test, can you simplify it using source transformation multiple times? Yes. It might be even easier than dealing with node voltage. Now any method should work. If I bring you, for example, this is a very common example in the book. And I tell you, is this an open circuit?
Yes.
What is the current that goes here?
0, 0.
Always open circuit. So if I tell you what is VAB, which is same as V open circuit, well, let's say I'm not gonna solve a numerical, it's conceptual. Let's say this is R, 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 R. You do source transformation, this is V. So if you do one source transformation, you will have, and then you will have R in parallel with this R is that R. And this R is this R. So what's the value? It's V over R, right? And then you have this resistor, and you have that resistor. And then you have AB. R in parallel with R, can we simplify it?
R over 2.
It's R over 2. In the old exams, they love having R's, صح? صح? Not always they give you numbers. So what is this? R over 2. And what is this? R and R. Do another source transformation. You multiply these two, what you will get? Keep in mind the polarity is same as the direction of the arrow. V over R times R over 2.
V over 2.
It's V over 2. And what is this resistance?
Oh.
R over 2. In series with R, in parallel with R, and you're looking at AB. Get it? So, simplified, it will be a voltage source of V over 2, 3R over 2, another R, you still have A and B. Another source transformation, what you will have? Current source of V over 2 divided by, or which is divided by 2R over 2. صح? 3R over 2. So it will be V over 3R. Right?
Yes.
And then you will have what?
Umbrella.
2R parallel with 2, 3R over 2 parallel with R. What is that? It's going to be 1 over R plus 2 over 3R inverse. Multiply by 3, multiply by 3. 5 over 3R inverse, so that's equal to 3R over 5. So the final answer should be what? 3R over 5.
Yes.
No. Don't skip steps. V over 3R, and that's a 3R over 5. So this is Norton or Thevenin? Norton. So what is I Norton? I Norton is V over 3R. What is R Norton, which is R Thevenin? 3R over 5. Now what is R Thevenin and V Thevenin? R Thevenin is same as R Norton. What is V Thevenin? Multiply, so it would be 3V over 15. No, V over 5. V over 5. Do you love this problem?
Yes.
I just came up with it.
السؤال هذا هل كان يحتاج ان الفولتج يكون سيريس مع الار بالبدايه؟
Which voltage?
في البدايه اول شيء.
Yeah, of course. This voltage is in series with that R.
لو كان هذا مثلا كرنت فولت.
لو كان هذا current, it's irrelevant.
ما ينفع.
ما له دخل، مسألة ثانية.
ممكن تلقى قلنا الكرنت سورس
بعيد شرح المسألة. This problem asks you to find the Thevenin equivalent, and Norton equivalent, and R Thevenin. We said R Thevenin is the same. What makes this problem tough is everything is R. And students, when they don't see numbers, they get panicked. Because it's very easy. In the multiple questions, Dr. Atiyah will put us V over 5, V over 6, V over 7, V over 8. Yalla, you have to solve it using source transformation. Because if you don't solve it using source transformation, you will have V1 minus V over R plus V2 over R will there. And yeah, I'll explain it again. But you have questions?
دكتور اذا هو بس اذا يبي الار ثبل نقدر نجيب نقدر كل ذا سورس برضه اذا يبي الار.
You can, if you kill the source, what is R equivalent? Yeah, it's R. If you do it, it's what? R over 2, R, parallel with R, 3R over 2, parallel with R, and it's the same. But if he asks you to do what is V Thevenin? Again, how to do source transformation? Voltage source in series with R, so that will be a current source, V over R. You take this R, you put it in parallel with that R. R in parallel with R is R over 2. This block, you do another source transformation, it will be R over 2 times V over R times R over 2. So this will be V over 2. Now you'll have R over 2 plus R, they are in series, so that's a 3R over 2. And the voltage source is V over 2. And then there's an R. Another source transformation, this will be 3R over 2. And you have to divide V over 2 over 3R over 2, you will get V over 3R. Parallel combination between 3R over 2 and R, you will get 3R over 5. The current source is V over R, 3R. That's Norton equivalent. To convert from Norton to Thevenin, R Norton is same as R Thevenin, and the voltage sources you multiply. It's going to be V over 5, and that's the final form of this very important problem that will come maybe in the test. Yes? Which series? 1, 2, 3. 3. What's wrong with 3? R is series with R over 2. Because I converted this block using source transformation, which is this block, without this R. You have to study source transformation very hard.
دكتور حول الفولتج سورس الى كارنت سورس بعدين رد الفولتج سورس.
You have to swap, yeah. تلعب.
طيب الى متى؟
Well,
صدق
it's a technique.
يعني كم مره حول؟
Yeah, multiple.
الى ما تحصل
إلى ما تحصل فاين Thevenin. R Thevenin والنورتون تصير عبارة عن مقاومة وفولتج source. That's why you're here in the help session, because we did not solve this example in the lecture. And some students who are lazy, who didn't want to stay on campus until 6:30, they're missing it. It's very important. Okay?
دكتور
في حد مع مناديل يا شباب؟
can we use
voltage divider rule. First we find.
You can use it, but I'm solving it intentionally using source transformation. يعطيك العافية. Thank you. You can use VDR, but source transformation will save you.
Because I found it easier.
If it's easy, give the same answer. I don't care.
ما اقدر يجبرني على الطريقه صحيح الدكتور.
اختيارات. 18 questions.
عشان كلها مش.
Well, you will get lost. Well, sometimes the question may give you mesh counterclockwise. You need to try to solve it. What if he already gave you mesh counter? Can you solve it? Again, voltage rise, voltage drop. Yes.
تقدر تعطينا دكتور نصائح للريزستيف سيركت؟
Resistive circuit? Well, it depends.
يعني زي الواجب السؤال الاول والسؤال الثاني كيف تسوي جيب الارم؟
We can. Okay. There was a question. Let me erase the board first, because I have to think about another concept. Do you guys remember this circuit that looks like Wheatstone, but it has
Yes.
this one?
مليان كتابات.
Huh?
مليان.
And then what? There is a short circuit here? This looks like Wheatstone bridge, except we have a voltage source instead of a current meter, right? And also there was an old exam question that one student asked me about. Maybe those two problems, when we solve it, it will answer your question. Keep in mind, if two elements, they share two nodes, they are in parallel, regardless. Which is problem homework 1, figure 2. All the three resistors on the right, they are in parallel. Because they satisfy the parallel requirements. But there was a question in the old exam. But let's start by solving. Anybody can give me this question from the book?
Yes.
You have the book?
Yes.
Chapter 1. You asked me before about it, صح? What are the numbers?
Yes.
اقدر اقول انها برا يا دكتور.
Well,
العلمي بعيد صح؟
this one and this one is in parallel with this one and that one. So these two are parallel.
دكتور هي اللي فيها ار اكس ولا مو هذه؟
لا هذه Wheatstone bridge اللي فيها RX.
هذه بس انا ما ادري اكزامز نفس.
Yeah, can I see it please? No, that's different.
ما في الا واحده حق ار اكس دكتور.
هذه
No, chapter 1. أيوة هذه. يعطيك العافية. 2 6. Yeah, it's RX, yeah. Now the polarity is not clear here. It's okay if I put it that way, right? And he's telling you for the 6, I equal 1.2 amps for Rx.
And two.
So this thing is same as that thing, doesn't it? How to solve this example? Well, you can do it with basic KCL, KVL. So what you need to know is you need to well, what is the question? Consider the circuit. Which elements are in series? Which elements are in series? Any elements are in series? No. Which elements are in parallel? Clearly, the 6 ohm resistor is in parallel with the 4 ohm, and the Rx is in parallel with the 2. Because they have the same node. 2, 3, Same node. They share this node and this node. This node is effectively that node. Now, apply ohms and KCL to solve for Rx. You need to know Rx.
ما اقدر اقول ان الضلعين اللي فوق بارامل اللي في فولتج سورس صح؟
No, you can't say these part. But let's do it. So you can define KVL. So what's the current here? Let's call it I2 ohm. I6 ohm is 1.2. So what you can, I'm not gonna solve it, but I'm gonna give you some hints, okay? Is the voltage here same as the voltage here? Yes, because we are connecting them with short circuit. That's one thing to know. So you can start by KVL here. So let's do KVL. Plus some minus, plus some minus. So we can do a KVL around the triangle. So what we have is voltage rise, 10. You do minus 10. Voltage rise and voltage drop.
Rise.
Rise plus no passive sign convention,
Yes.
right?
2
2 I2 ohm
Yes.
minus 6
Drop. Minus.
times 1.2 equals 0. Can I solve for I2 amp? 2 ohms?
Yes.
What is the answer? Well, it's 6.6 times 1.2 minus 10 divided by 2. What's the I2 amp?
Minus 1.4.
Minus 1.4
Ampere.
amp.
لأنها عكس صح لأنها
So I solved for this current. So what is this current? I short circuit. I short circuit. You can call it I total. So I short circuit equals I 2 ohm plus I 6 ohm, which is 1.2 minus 1.4, which is minus 0.2 amp. So I know the current here is minus 0.2 amp. It is negative. Just keep it as it is. It means here is 0.2 amp. Now you have to find, do another KVL. So you already know this current. So what is the current that is entering here? Is 0.2. So 0.2 gets distributed here and there. Okay? Now, you can think about any other way of solving it.
Can you do KVL?
You can do another KVL. So you know that this is a 0.2 minus that current. صح? So I 4 ohm is actually 0.2, which is I short circuit minus I Rx. So you can say plus minus, and do another KVL at the lower triangle. But the key here, the trick, is you have to know that I 4 ohm is 0.2 minus IRX. So you will have a KVL here with only one variable, which is IRX. But there is another problem. IRX, we don't know RX. Okay? So
دكتور ما ينفع اسوي KVL من برا؟
you can do an outer KVL. We can do KVL here, but this is a 0.
من 4 ohm
Well, I have another suggestion. This Rx, this is 2. Can we do, we know these two are in parallel, صح? Can we use a CDR at 6 and at 4? So at 6 we have here we have what? Minus 0.2 goes through 6. And here, let's check something. Anybody has an idea?
Current divider rule.
Well, we already know the voltage drop here, صح? We already know the voltage drop here. وين الساعة؟ Don't I know that the 4 ohm resistor is in parallel with the 6 ohm resistor? So what is the voltage drop here? It's 6 times 1.2, plus and minus. So minus and plus, so this is minus and plus. So I can know the current that goes through the 4 ohm resistor. So if I know the voltage drop here, then the current that goes from positive to negative, which is I 4 ohm, I can know it. So I 4 ohm equals 6 times 1.2 divided by 4. So now I calculated this current. What's the answer? 1.8 amps. So here I know I have 1.8 amps. Given that I know that these two resistors are in parallel, they have the same voltage. So what is IRX? IRX equals 0.2 minus 1.8, which is equal minus 1.6. So here I have minus 1.6 amp. We repeat the same trick. We have the 2 ohm in parallel with the RX. Keep in mind I put the polarity the same. Plus, minus, plus, minus. I put the plus here, the plus here, the minus here, the minus here. So they have the same polarity. And what is this 2? What's the current at 2? We already calculated I2 amp, minus 1.4. And I already know what's IRX, minus 1.6. So Rx times minus 1.6 equals 2 times minus 1.4. So what is Rx? 2 times minus 1.4 over minus 1.6. What's the final answer?
1.75.
1.75. Get it? This is one of the big examples of. Take a photo. Or watch YouTube. Can anybody verify it? Yeah, it makes sense, صح? If this is 6 and this is 4, this is 2, it's 1.75. Now, I could be wrong. If I make a mistake, contact me. هذه it's just an extra thing we do.
لا مضبوط.
مضبوط؟
لنا بالأوفيس اور مضبوط طلع لنا نفس النفس.
1.75? We did in the office hours, صح? See, the students who come to the office hours, they're already ahead of you guys. They will get the A plus from you. And Dr. Atiyah students, you know. By the way, most of them, they're way ahead of us. But hopefully, inshallah, we will do better than all the sections, including Dr. Ahmed's students. Dr. Ahmed's students, do you see the difference what we do? Voltage rise, voltage drop?
Yes.
Do you see the difference? Minus plus, plus minus, سهلة. ما في فرق كثير.
الساين بالضبط عكس.
عكسين بس. كملوا على طريقتكم.
بس لو اعتقد ان احنا اذا سوينا كاونتر كلوك وايز يكون نفس
إذا لا تلخبط. So let me do another review question from the old exams. Any question you want me to do it from the old exams?
أنا عندي question.
But before, أنت عندك question من old exam?
لا لا question.
طيب, let me look at one of the questions from the old exam. Not this. Not this. I have to find it. It's a very good question.
دكتور الحين
على المش
Sorry.
تشرح الحين ريفيو الكونسبتس اللي غير
I'm covering some tough problems, بعدين we will go over review. أحسن. I'm trying to find. I forgot the circle. But anybody remembers from the old exam we have A, B, and then we have something like that. A, B, بعدين circle شيء زي كذا.
طيب دكتور شو جوتي؟ هذه
Yes, this problem. Let's solve this. أي old exam هذا؟ هات بصوره. Let's review the concepts real quick, صح? What do I want you to learn? Then we'll go to the tough problem. So let's take a break. Breathe. Hatem, you just come here. What's that? Let's see. And also I have to monitor the camera. 57 minutes of recording. Can I take 1 minute break? Or 2 minutes? I started to have titles in my videos, okay? We will have titles, more titles in the future, but the old ones I need to do it later. I don't have time to do it now. So let's start. I want you to know very few concepts important in the test, okay? Review. Concept number 1. I'm not going to go in order, but I'm going to visit various concepts, because if we start from order, those are skills. We need to connect all of them together. Let's start with the voltage divider and the current divider. If I tell you there is a battery and there is a battery of voltage V, resistor R, and then here I told you here we have 2 resistors. I'm going to say 3 resistors, R, 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 and then I'm telling you here you have 2 resistors, okay? Can I replace these 3 R's and these 2 R's with single resistor, single resistor, single resistor?
Yes.
So can I write it as this form? R, 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 and the voltage here, V, would appear here. R, here what I'm going to have? R over 3, R over 2. If I tell you, if you use voltage divider rule here, then you will have, for example, V2 equals R over 3 divided by R over 3 plus R over 2 plus R times V, source. This is another way of looking at the voltage divider rule, okay?
لازم تكون series.
Well, the key about the combination has to be in series. You studied that, صح? The combination has to be in series. And again, in all the exams, they